I'm Janardhan from Southern Regional Dispatch Center, Posoko. The basic aim of this paper is just to give you an idea about how much flexibility is required by 2022 for the southern region with 55 gigawatts of wind and solar installed capacity. And see, what is the motivation for this paper is we are having target of installing 175 gigawatts of renewables by 2022 in Indian grid, out of which 55 gigawatts wind and solar is going to be installed in southern region. And this wind and solar, they are characterized by variability and intermittency. So to balance the load and generation is the main responsibility of a system operator. So to have an idea how much flexibility we have to get from conventional generating sources, this paper is made. And here we have given this net load concept. Net load is actually the difference between actual load connected in the grid and the generation from wind and solar. Suppose you take for tomorrow the forecasted demand in the grid minus the forecasted wind and solar generation from wind and solar gives the net load for tomorrow. The net load gives the system operator a fair idea how we can balance the variability of renewable generation with the conventional generation. And here I wanted to give a small introduction to southern region. Southern region consists of 5 states of India: AP, Telangana, Karnataka, Tamil Nadu, Kerala, and Union Territory, Pondicherry. And our total installed capacity is of 93 gigawatts, and we have met a peak demand of 43 gigawatts. And presently our renewable capacity is around 22 gigawatts. Now, with this 22 gigawatts, we have reached renewable penetration, just wind and solar penetration as high as 36% during this July at some instant. At that instant, we were meeting total 33 gigawatts of demand from 13 gigawatts of wind and solar. And over the month, total July month, the average penetration was 22%. And now I want to give a definition of time block. Time block is a 15 minutes time slot starting from 00 hours of a day. So 00 hours to 00:15 minutes is a first time block, so that we are having 96 time blocks in a day. In this, we have studied the generation characteristics of solar park, which is of 250 megawatts, which is located exactly in the middle point of southern region, not towards east side or not west side. And wind power variation in southern region. This wind power variations also, these are specific to southern region. And expected net load by 2022. And we have taken the demand, expected demand from EPS, Electric Power Survey, peak demand. And we have given the present solutions, what solutions we are having for managing the ramps, and what further requirements are there for managing these ramps. And these are the solar generation characteristics. This time scale I have given is in time blocks, 1 to 96 blocks. Usually the generation starts in the 24th time block and ends in 73 time blocks. And the generation starts increasing from 25 time block onwards up to 49 time blocks. And each time block, the increase in generation, the ramp in the generation is different. I will show in the next slide what are the ramps in different blocks. And the next 3D plot of megawatt generation in megawatt for over a month. You can see that in addition to this intraday variation, there are variations in intraday variations. In this paper, we have not considered this intraday variations due to cloud cover and all. We have just considered the general characteristics of solar generation. And that right side, that curve shows the ramping. As the day progresses, the ramping up in the generation increases. And again the ramping up in the generation decreases. So each time block has its own ramping. And here we have summarized approximately, we are divided into 7 ramping summary. And in the blocks 26 to 27, 2.2%, and 28 to 38, 5%. This is of 5% of installed capacity. And some blocks we have seen up to 6.5% of installed capacity. This is the addition in each time block. So as the day progresses, there will be increase in the generation up to in the afternoon 12:30, and after that there will be reduction in the solar generation. that is with respect to solar, and these are the wind power variations. This is specific to southern region. The first graph is the wind power generation in wind energy generated over a day, got it for 1 year. The time scale is 1 year. You can see that June, starting of the June, the wind generation peaks, and up to September, it will persist. So other times, the wind generation will be minimum. That 3D graph shows the peak region in the middle for June to September. And one more good thing is in southern region, peak wind generation has specific characteristics, and non-peak means wind generation has its own characteristics. Those two are specific characteristics, and they are means almost same during that wind generation, that period, peak period. You can see that this morning hours wind generation will be less during peak wind season, and it peaks up at the 24th time block. Same thing starts with our solar generation also. So at the same time, solar generation and wind generation, they are started peaking. So here we have to back down our conventional generation to accommodate these renewables. Whereas if you see in the wind season, morning hours and night hours only wind generation will be there, whereas during afternoon hours there won't be any wind generation. Here I have given for specific to high wind season. Here morning hours the wind generation will be less, and it will peak up, which is coinciding with the solar generation peaking. And that is for wind season, it is exactly opposite to solar generation. So here the ramping requirements will be less. These are the characteristics of wind and solar generation specific to southern region. And now we have taken the expected peak demand of 2022 for southern region is about 63 gigawatts given by Electric Power Survey 19th, and we have the wind installed capacity is to be 28 gigawatts by 2022, and solar capacity is 26 gigawatts, which forms around 38% of our total installed capacity. And now net load definition I have already given. There is a difference between what is the actual load and what is the expected generation from wind and solar, which gives us an idea about amount of flexibility you need to provide for accommodating the generation from wind and solar. Here we have considered two scenarios. One is peak demand season, peak demand of southern region, which occurs during March and April season. And the March and April season is lean wind season. There won't be any wind generation during that March and April. And in that peak demand scenario itself, we have considered two scenarios. One is 80% of our RE targets by 2022 achieved, with 100% of RE target achieved. And here that right side curve shows, the top blue dotted curve shows the actual demand, and down orange curve shows the net load with 80% of targets met, and green dotted curve shows net load with 100% our RE target. 100% is 55 gigawatts RE targets met. And here with this 80% orange curve, in the 28 time block, our net load was 55 gigawatts, which came down by 41 gigawatt in the 49th time block. So you require a 14 gigawatts of backing down from our conventional generation. Maybe it may be from the thermal, hydro, whatever it may be, in 21 time blocks. And the ramping requirements, the ramping down requirements in each time blocks are given here. You can see that first 1 to 25th time blocks, that is because of variations in our demand. And whereas from 25th to 49, this is the solar ramping up. So solar ramps up, so we have to ramp down our conventional generation. Here wind generation variations are less because the this is green wind season. And again there are ramping up requirements, so we have to bring more and more conventional generation. That is because of ramping down of solar generation. And here with 80% of our RE targets during peak demand season, we are 1000 to 1500 megawatts each time block, each 15 minutes time slot, we have to back down 1000 to 1500 megawatts of our conventional generation. Similarly, we have to in the afternoon session, afternoon hours, we have to bring 700 to 1000 megawatts of conventional generation for balancing the renewable generation. In the 100% target scenario, it is going up to 1500 to 2000 megawatts. and similarly in the afternoon hours plus 1000 to plus 1500 megawatts. And specific to this scenario, the demand is high, whereas wind generation is less. So we are having more thermal generation on bar. So for catering our demand, we will be having more thermal generation on bar. So we can expect more flexibility during this season. And this is the expected net load. This is in peak wind season, which is in June, July season and August. June, July, August season. That top curve, as usual, that is the actual load, and orange curve with 80% of targets met, and green curve with 100% of targets met. In this, the net load of 41 gigawatts in 28 time block, it has come down to 21 gigawatts. Almost 20 gigawatts backing down is required from our conventional generation. Here it is coupled with increase in wind generation and increase in solar generation. So the ramping requirements you see as high as 2000 megawatts in 80% of targets itself. If you see 100%, if our capacity goes up to 55 gigawatts, then ramping requirements are about 2000 to 2500 megawatts. And one specific to this scenario, June, July, this is the July starts with monsoon season. Monsoon starts, so we will be having some amount of hydro on bar. So we can expect some flexibility from hydro. And for managing these load ramps, what are the solutions we are having? We are having the thermal generation flexibility, and by 2022, the thermal capacity in southern region is expected to be 72 gigawatts. We have made a small case study on that, considering only 65% of the capacity is on bar, and it is running at a capacity of 80%. Means the generators are loaded up to 80% due to high wind generation. So at that time, we are expecting a flexibility of 10 gigawatts from thermal generation, whereas our requirements during high wind season is up to 20 gigawatts. And from hydro, we are getting, this is everything is with respect to southern region. Hydro generation, we are getting up to 3 gigawatts. So remaining, how we have to manage? We are having storage options, pumped storage. Presently, we are having southern region pumped storage of around 2000 megawatts pumped storage is there. In that, we are able to use only 400 megawatt due to various reasons, and it has to be, it is under rectifying stage. So we will get 2000 megawatts of pumped storage on board. So we can get plus 2000 to minus 2000 flexibility in that. And one more thing is the storage. Here CEA technical standards, they have given a requirement of mandated a requirement of 10% of installed capacity to be it has to come as a storage with the plants itself. Wind and solar plants, they have to install 10% of storage along with the parks. And one more option we are having is exporting this excess power to other regions. Maybe we are having surplus power. If any chance is there, we can export the power to. Anyway, our southern region is connected to other regions through AC interconnections, and one more HVDC is planned of 6,000 megawatts. So we can export power to other regions. And one more good option we are having is altering the load curve. Our southern region, we are having agricultural load up to 30%. So what our states are doing is they are dividing the total day into 3 shifts. So they are giving loads, certain loads. Suppose 100%, 33% of loads they are giving in shift A, 33% in shift B, shift C. So we are having high generation from renewables during the daytime. So total shift A, shift C loads also we can shift to during daytime. So like this means we can change the demand curve itself, which can be better for accommodating the renewable. And one more thing is here we have assessed the net load requirements for southern region, total southern region, whereas in our country we are having each state has to manage its own portfolio, its own control area. So specific to state also they have to assess so that can be better managed. This is with respect to general characteristics of solar generation variation and wind variation. Whereas other variations in solar generation due to cloud pass. If cloud passes, there will be reduction in the solar generation. What are the options for managing that type of variations? Main is first line of defense is our primary response, governor response. We are having all the generators which are in specific to our Indian RGM or restricted governor mode. We are presently in southern region. We are expected of 800 megawatts in case of any contingency of up to 1000 megawatts. If anything trips, we are expected of 800 megawatts response from the generator, whereas we are getting presently 200 to 300 megawatts. It is to be improved, and it is getting improved nowadays. And automatic generation control, AGC, presently in Indian grid, AGC is under pilot project stage. Soon it is going to be deployed in the grid. If any variations in the renewable generation, it leads to the deviation in taiga inflows. So to maintain the taiga inflows, this AGC senses the deviation and gives signals to our conventional generation, so to increase the generation. So AGC is going to come in Indian grid, and ancillary services. Presently, Indian specific ancillary services are in place, which are in central sector generating stations only. So it has to be extended to up to state sector generators also, so we can get more flexibility for accommodating this. With all these solutions like storage options and exporting and altering the load curve, we can better manage the grid with a high penetration of renewables. Thank you very much.
Thank you very much. Any questions from the audience? Yeah, there's a question over there. Microphone is coming.
Hi, my name is Pavitra. I represent DNVGL. So thank you for the presentation. So my question here is, when you balance for the renewable energy penetration, it is not necessary that the balancing resource is quite closer to the renewable energy location as well, electrically.
Yeah, no.
So that has to be taken care by the transmission upgrades and the grid enhancements as well, right? So the solutions, apart from the ancillary services and the other solutions that you have included, I think grid enhancement also marks as an important solution. Don't you agree?
Yeah, that export to other regions, that is one of the options. Like with other regions also, we can balance our variations in renewables. Yeah.
And even within the state. So to the load, to serve the load, it has to come from some transmission, right? So the congestion in the transmission has to be addressed as well, because the source will be somewhere else and not from the renewable energy source. In terms of, like, whenever the wind is off or the sun doesn't shine, it has to be accommodated as well, right?
Now, there is no congestion as a part of southern region. There is no congestion, means how much of power we want, any state wants to get, there is a proper transmission system is in place. Except for Kerala state, there is some congestion problems.
Okay.
Other states are, which are renewable rich states, they are having sufficient transmission capacity which can import power from any of the state or any of the regions also.
Okay. Even within the state?
Within the state also, yeah. Within the state, anyway, states will manage that. States will get the power from within the states. Within the states also, there is no congestion like that thing, no.
Okay. Okay. Thanks.
Yes.
Can you just wait for the microphone? Sorry. Just the microphone is coming.
The congestion, what we have seen is at a distribution level we have seen. And at transmission level, there is sufficient capacity is there. Now, one state in southern region, it is already doing same thing. And we are expected congestion in the distribution side, and they are facing congestion in distribution level itself. So, their argumentation they are doing.
But after all, power is used by distribution network.
Yes, correct. That augmentation, that is also planned. That state, they have planned additional transformers and 33 kV lines, everything they have planned at the distribution level.
Okay, there's a question over there.
You spoke about altering the load. Maybe you could look into Government of India's policy on electric mobility. Because what we see from the documents, about 6 to 7 million vehicles by 2020 and 100% electric mobility by 2030. And of late, we see also some amount of actions on that side. So I don't know how much load it will be translated into, but that is one component you can see in terms of load. Yes. Both sides, from demand side as well as supply side.
Okay, any further question? I have, just for my understanding, two small questions. One thing, what is your experience with forecasting load in general, long-term load for the next couple of years? So I've worked in many countries where they overestimated the load growth quite a lot. So what is your experience here in India?
So the load forecast is actually it is on the side of relative over forecasting. It is almost matching. Our experience was it is almost near to that, but the forecast was over forecast relative.
Okay. The second question is, many of the wind turbines that you have at the moment installed are quite old wind turbines in the south. And they have a different power curve than the new wind turbines that you're getting in now. And I think that's something you have to consider, that the power output will actually change depending on the wind condition. If you just consider the power output of the old wind turbines, the new wind turbines, they have in certain regions, in certain wind speeds, quite different percentage of power output. Have you considered the different power curves there?
Sir, we are not gone into that deep. Our aim is to give a fair idea how much, based on previous experience and recent experience during July, we wanted to present how much net gain is expected during that 2022. That is to be further study we have to do. Means we have to go up to turbine level, what is the characteristics and
I think you don't need to go down to the wind turbine level,
yes.
but it's just more the general assumption what kind of the contribution of the wind power is at different wind speeds. That will probably change when you have large-scale new type of wind turbines coming in the system. There's a question over there.
Well, right. As the forecaster for in Tamil Nadu, we are the chairman of the Indian Wind Power Association, is doing forecasting for 7,860 megawatts of wind installations in Tamil Nadu. On the static data of capability of the wind machines installed, either it is old, 20 years old, or installed last year. The power call and hub height is embedded into the forecasting system, and the capability of the old generator as well as the new generator are taken into account in forecasting.
Okay. But it's also considered in your study then?
further, our study further will be considering that down.
Okay.
Yeah, wind turbine.
Okay. Any other question from the audience? Comment? No? Okay, then thank you very much. Then I would like to
Thank you
move
very much.